Find the eigenvalues and eigenvectors of the matrix 7, 3, 3, negative 1. To find the eigenvalues, I start by subtracting lambda from the entries along the main diagonal to get 7 minus lambda, 3, 3, negative 1, minus lambda. And then take the determinant, which equals 7 minus lambda times negative 1 minus lambda minus 3 times 3. The eigenvalues of A will be the values of lambda that make the determinant equal to 0. So I need to solve 7 minus lambda, negative 1 minus lambda, minus 3 times 3 equals 0. Foiling and combining like terms, I get that negative 7 plus lambda minus 7 lambda plus lambda squared minus 9 equals 0. So lambda squared minus 6 lambda minus 16 equals 0, which factors as lambda minus 8 times lambda plus 2 equals 0. So the eigenvalues are lambda 1 equals 8 and lambda 2 equals negative 2. Now to find the corresponding eigenvectors, we start by plugging an eigenvalue into 7 minus lambda 3, 3, negative 1 minus lambda, and then solving 7 minus lambda 3, negative 1 minus lambda times the vector x1, x2 equals 0, 0. For lambda 1 equals 8, we need to solve 7 minus 8, 3, 3, negative 1 minus 8 times x1, x2 equals 0, 0. So negative 1, 3, 3, negative 9, x1, x2 equals 0, 0. Notice that the second row is just negative 3 times the first row. This shows us that yes, 8 is an eigenvalue and that it doesn't matter which row we use to find the eigenvectors. I'm going to go ahead and use the first row, which translated from the matrix equation says that negative 1 x1 plus 3 x2 equals 0. So x1 equals 3 x2. To find an eigenvector, we can choose any non-zero value for x2 we want and then calculate the x1 that goes with it. I pretty much always choose x2 equals 1, which for this problem gives me that x1 equals 3. So 3, 1 is an eigenvector, and so is any non-zero multiple of 3, 1, since we could have chosen any non-zero value for x2. Repeating the process for lambda 2 equals negative 2, we need to solve 7 minus negative 2, 3, 3, negative 1 minus negative 2, times x1, x2 equals 0, 0. So 9, 3, 3, 1, x1, x2 equals 0, 0. Remember, it doesn't matter which row we use, so since the second row has smaller numbers, I'm going to use it this time instead of the first row. The second row tells me that 3x1 plus x2 equals 0. So this time I'm going to solve for x2 because I can, which shows me that x2 equals negative 3x1. Choosing x1 equals 1, x2 must equal negative 3, so 1, negative 3, and any non-zero multiples of 1, negative 3 are eigenvectors. To summarize what we found, the vectors c times 3, 1, where c is non-zero, are the eigenvectors of our matrix A corresponding to the eigenvalue lambda 1 equals 8, and the vectors c times 1, negative 3, where c is not equal to 0, are eigenvectors of our matrix A corresponding to the eigenvalue lambda 2 equals negative 2.